Welcome to today's lead code problem solving session. Today's problem is 1052, Grumpy Bookstore Owner. So it's a medium problem and it goes like this. There is a bookstore owner that has opened a store. Does the store open for n minutes? Every minute as some number of customers enter the store. You are given an integer array where of integer array customers of length n, where customers I is the number of customers that enter the store at the start of the ith minute. Okay. And all those customers leave after the end of that minute. Okay. On some minutes, the bookstore owner is grumpy. You're given a binary array grumpy, where grumpy I, okay, is 1 if bookstore owner is grumpy during the ith minute, or 0. Given the bookstore owner is grumpy, the customer so of that minute are not satisfied, otherwise they're satisfied. Okay. The bookstore owner knows a secret technique to keep himself not grumpy for minutes. For uh, okay, the bookstore owner knows a secret technique to keep themselves not grumpy for minutes, consecutive minutes. Okay, so like here 3 consecutive minutes, but can use it only once. Return the maximum number of customers that can be satisfied. Okay. Hmm. Interesting question. Basically, if you say minutes 3, you can like choose a window of 3 somewhere to make sure that those customers are not grumpy, and one is grumpy, right? So what we're looking to do is the store here looks like um, 5 kind of takes it all, because there's 5 and there's 1 here. So yeah, the bookstore keeps themselves not grumpy for the last 3 minutes, right? Interesting. I guess like the way I would do is some kind of like sliding window, uh, right? To check which window of 3 minutes. So I'm basically gonna count the total number of uh, satisfied customers. Plus, I'm gonna have a sliding window where uh, I can have like I can basically count the number of grumpy customers within those minutes, and wherever that window is the highest, we basically turn those customers into unhappy. Sorry, we turn the uh, bookstore owner ungrumpy, so the customers in that window are satisfied. Hmm. Interesting. Based on the previous questions, I would assume it's like a binary search. Oh no, it is a sliding window. Okay, I think so. Lead code has changed its topic for the daily problems, and it is a sliding window. It's just the so the approach is pretty clear. So like just to get the start and end values correct. All right. So it's gonna like keep two variables called current and max, uh, max grumpy, and also uh, non grumpy. Let's say. So yeah, and for I in range, it's kind of like a two-part solution. But yeah, I don't wanna, I don't want to create a big loop and a small loop to check if the if I is greater than like minutes to remove the left, the ones out of the window. So I'll just add one to the window and like just remove the next ones. For I in range minutes, um, the P I. So we add this to current grumpy or this C actually just for like sake of it. So this would be customers I, yeah, else non plus customers I. Yeah, just gonna remove max grumpy from here so I can just assign this directly. Sorry, max G is current grumpy, and for I in range minutes to the end now, so that's length of um, customers. So we basically remove the previous grumpy and add the new grumpy. Yeah. So previous index would be like I minus minutes, right? So if, but we remove them only if uh, grumpy I minus minutes is equal to 1. So yeah, grumpy minus minutes. Oops. Oh, customers minutes. And if the current value is in grumpy, we add that. Been using like different keyboards recently, so yeah, customers I Else we can just add it to non-grumpy. Yeah, also like replace the max. And if it's not grumpy, then yeah, we just add this customers and we return basically non-grumpy and the max like pocket of grumpy people, max window of grumpy people. Yeah, so that should be the solution, and it does work. Let's see if submits. I don't think there's like any. Yeah, it's one, and minutes is guaranteed to be like less than equals to less than or equal to n. So that should be good. Yeah, yeah. It's a good performance, easy problem. Sure, they're all the same thing, but the names are much wider and they use like one single loops, like single, what are they called, ternary operators or something. I'm sure. One liners. So yeah, I guess that's all for today. Thanks for watching. Peace.